Hello class, and welcome to another video tutorial. The topic on development so far has come to an end, and those that participate in the two assignments did very well, though the participation is low. As many that are still working on the assignment, please do, and then let me have them when you're through. Today we'll be looking at the topic before us, which is on the screen: dimensioning, or what we call dimension techniques. Dimensioning or dimension techniques. Learning competencies. Upon completion of this topic, you should be able to 1. Know the importance of dimensioning. Identify the basic element of dimensioning, such as dimension line, arrowhead, extension line, etc. Distinguish between a line system of dimensioning and on-directional system of dimensioning. Differentiate between size dimension and location dimension. Understand the difference between the various types of dimensioning, and also understand the rule of placing of dimension on views. Now these are the things, these are the learning objective for this topic. So we'll be covering all of this in possibly in this video. This might not have a practical video tutorial. It's expected that the next topic will be putting this topic into use. Okay, so we'll try as much as we can to understand properly each of these learning objective. Dimensioning. Now, in technical drawing, we communicate with shapes, symbols, and also with letters and figures. While lines, symbols, and shapes are used to while lines are used to describe shape, we also use figures to describe size, and that is where dimensioning or dimensions comes in. Okay, now lines are used to describe the shape, while figures are used to describe sizes, and those figures used in describing sizes is what we refer to as dimension. Okay, then the process of putting this together is what we refer to dimensioning, where you have your dimension line, your arrowhead, your extension line, your dimension figure, and all of that. All of them put together is what is referred to as dimensioning. So from our notes here, we have some pointers here. Dimension is the measurement or extension in a particular direction, namely length, breadth, and height. Take for instance, in a classroom, from one end of the classroom to the other, what is the distance? That is what is meant by dimension. Okay, a distance from point A to point B. What is the numerical value of that distance is what is referred to as dimension. Okay, now let's have this. Supposing we have point A, and we have point B. Okay, point A and point B. Now the distance between this point and this point A and B, okay, this distance, what is this distance? Is what is called the dimension. Okay, that distance is called dimension. It could be, let's say, 50 mm or 50 cm or whatever unit of dimension being used. That distance is called, that figure, this is called the dimension. Okay, or sometimes the dimension figure. Okay, now if we look at this, if we look at this symbol here, if we look at this figure here, okay, now we have the numerical value, which is the dimension. Okay, we have extension line, we have dimension line, we have arrowhead. Okay, a combination of the numerical value, the extension line, the dimension line, and the arrowhead form what we call dimensioning. Okay, so dimension is vital in preparation of machine, architectural, and other engineering drawing. The drawing itself shows the shape, like I said before. The drawing itself describes the shape, okay, which you use line basically to describe the shape of the object. The dimension shows full size of the object. Okay, the dimension shows the numerical value of the object from here to here. What is it? 10, 20, 30, and all of that. And without dimensioning, we cannot actually produce anything. Hello. Dimension make production possible, like we did in development. Okay, if you don't know the size of a cube, can you produce it? No. So it is very important we know sizes of objects before we can produce them. Okay, dimension should be kept simple as possible, as over dimension can be confusing. Yes, when a particular drawing is over dimension, it could be very complex and difficult to understand. So dimension should be kept simple and precise. A construction line should be used for dimensioning. Yes, when we talk about types of line, we say construction lines are used for projection line, dimensioning line, extension line, and all of that. So basically, a construction line should be used for dimensioning. Your dimension line, your extension line, your arrowheads should be made with a dimension line. So putting all of this together, we can define dimension refer to the numerical value used to give distance information between two specific points or sides of a particular feature. It can be placed centrally above or by breaking dimension line. So that is basically what dimension is. Okay, any of these definition can serve. A measurement or extension in a particular direction, that is, like I demonstrated before. Okay, a measurement of an extension in a particular direction. If this is this measurement So this measurement in this direction is what we call dimension, the numerical value in that direction. Okay, if the direction is like this is a dimension. Okay, the numerical value is what is referred to as dimension. So the next thing is form of dimension. The two basic dimension form while giving a size of a feature are dimension and a note. Okay, we have the dimension, we have a note. Now in technical drawing, we communicate both with line, shape, symbols, and also with letters. Now while lines, shape, and symbol are used to describe the shape, letters are used to describe parts that cannot be described with the use of line, and that is when we have that note. So in dimension, we can have what we call a dimension and a note. Okay, a dimension deals with the figures, okay, the numerical figures, while note deal with something like, let's say you have an opening, a hole in a drawing, okay, or you have something that can not be described, or some specification that need to be described in written words. So the two forms are the dimension, which is the figure, and then the note, which is the word. Okay, so dimensions is the figure with numerical values, then the note is with letters. Okay, so these are the two forms. And then we have this as the various elements of dimensions. Okay, we have the numerical value, we have the dimension line, we have the arrowhead, and we have the extension line. Let's look at this in details here. Let's look at this in details here. Now, style of arrowhead. Arrowhead can come in different form. We have open style, we have closed style. Okay, we have the close, and then we have the close and fill type. Okay, as you can see here. Now the size of your arrowhead are in this form. Your arrowhead is in this form. You have this from here to here is 3 mm. Okay, 3 mm, 3 mm. From here to here is 3 mm. From here to this point is 1 mm. Okay, which is from here to here is 1 mm, here to here is 3 mm. Okay, here to here is 3 mm, here to this point is 1 mm. You have the open type here, you have the close but not fill, and then you have the close and fill type here. This is other method of or styles used in dimensioning. This is dot, this is oblique stroke, and this is common origin. Okay, common origin. Most often the close field in type is used for general purpose and oblique stroke for architectural and structural drawing. Okay, reading direction of figure. There are two systems of placing dimension based on reading direction of figures. Now, two methods of placing figures. If you can see in this diagram, there are two methods of placing figure. This is one, okay, and this is the other. This is one where you have a broken the dimension line broken at the middle, and you have the dimension figure in that space. Or you have this type that the dimension figure is placed above the dimension line. These are the two basic types. These are the two basic types. Okay, these are the two basic types. Okay, let's look at rules of dimensioning. Rules of dimensioning. The following rules should and must be taken seriously while dimensioning: accuracy, clarity, completeness, and relatability. Now, when we did in your first term, when we treat the topic on lettering, we did talk about rules of lettering, which is accuracy, clarity, completeness, and readability. Dimension should be accurate, they should be clear, they should be readable and suitable. Okay, very, very important. Very, very important. These are the four rules. Must be accurate, must be clear, complete, and readable. Dimension must not be ambiguous, that is, over dimensioning should be avoided by all means. Okay, unit of dimensions. Dimension in building are usually given in millimeters, like we usually use in our classes. Okay, all dimensions are in millimeter, otherwise specified. So in most cases we use millimeters. However, drawing may be dimensioned in meters, especially when figures are relatively large. It is, however, a bad practice to use both the millimeter and meter in one drawing. We don't combine different dimensioning system, okay, or unit of dimension. If you're using millimeter, make sure you use millimeter throughout. You don't use millimeter and centimeter together, no. You don't use millimeter and meters together, no. Okay, if it's millimeter, ensure it is millimeter throughout. If it's meters, ensure it is meter throughout. And when either meter or millimeter is used, it is not necessary to write m or mm after each figure. The distance alone numerically should be indicated, e.g. 250. However, an indication should be made on the title of the unit used, and that is why in your title block we ensure you have what is called a unit there, so that you can put the unit of your measurement. So on your dimension you just put the numerical figures, 200, 20, 10, just like that, and then on the unit you put the unit of your measurement. Is it millimeter, z, meter? You just specify it, and that is all. Line used in dimensioning, we've looked at that before when I talked about dimension line. Talked about line used in dimension. Dimension line is a thin, dark, solid line terminated by arrowhead, which indicates the direction or extension of dimension. In machine drawing, the dimension line is broken, usually near the middle, to provide an open space for the dimension figure. In architectural drawing, it is customary to place the dimension figure above unbroken dimension line. That is what you have here. Okay. In machine drawing you have this. In architectural drawing you have this. Okay. So this is what we call the dimension line. Okay. You come here, you also see it. Okay. This line here with the arrowhead is called the dimension line. You can see it here as well. This line with arrowhead is called the dimension line. Okay. Then we have dimension line. Dimension line should be approximately 10 mm away from the visible line. Okay. Alright. Now a situation where you have your, supposing we have this as an object. Okay, we have this as our object. Our dimension line, this is the extension line. You have this, you have this. This dimension line from here to here should be 10 mm. Okay, should be 10 mm. Okay. So this is it, from here to here. From your object to your dimension line should be at least 10 mm. Okay, that is what it means. Then dimension line should not cross each other. Okay, they should not cross each other. That is, you should not have something like this. Supposing you have something like this. Okay, supposing I have something like this and I'm to dimension this. I have this, I have this, I have this, I have this. And then this dimension line and this that is, dimension line should not cross each other. Now if you watch very well, this is a dimension line dimensioning from here to this point. Okay, from this point to this point, this is a dimension line. From this point to this point, this is the dimension line, and this dimension line is crossing this. Dimension line should not cross each other. In practice, no, it is not done. It's confusing, and that is not proper. So you have all of this here. Okay, this is dimension line, Okay, this is an extension line. There is always a gap of 1 mm between the extension line and the main object. Always a gap of 1 mm. Look at it. You have a gap of 1 mm here, you have a gap of 1 mm here, you have a gap of 1 mm all through. Okay, now from the object to the dimension line is 10 mm. Okay, from one dimension line to another dimension line is 10 mm. So that's why you have this arrow. This space is 10 mm, this space is 10 mm. You have this is the dimension line, we have this as the extension line. Okay, the extension line always extend 3 mm beyond dimension line. Okay, the extension line always extend 3 mm beyond dimension line. So if you are placing your dimension line 10 mm from the object, then your extension line should be 13 mm long. Okay, then when you are having something like this, you have one dimension, another dimension, then at this point you have something like 23, 26 or thereabout. Okay, so this is it. So you have as our extension line. We already know what extension line is, a gap of 1 mm. Okay, and all of that. Then we have the leaders. Okay, crossing of extension line. This and then this. Okay, for diameter, radius, fillet and chamfer, this is how they are dimensioned. Okay, so these are how circles are dimensioned. I think I have another diagram that will explain it further. Diameter and diameter dimensioning. You can dimension a diameter this way, you can dimension a diameter this way, you can dimension a diameter this way, you can dimension a diameter this way. Okay, the same thing goes if it's a radius. The same thing, instead of theta you use r for radius. Okay, instead of r you use theta. And then method of dimensioning, we have chain dimension, we have datum or baseline dimension, we have combined dimension. These are the three basic we considered here. Okay, three basic. Now you can see that this dimension continues to the end. Okay, we can decide to dimension this separately, decide to dimension this separately. That is what the second method is. Okay, you can see we can decide to put all of this dimension in this line. Okay, so the chain dimension has one reference point and all other dimension follow, while the baseline dimension have each segment separately. And a situation where you combine the two, you have what is called a combined type of dimension. Like I said, you get this, read the note, ask question. We will be using this in the next topic, where we'll be using all of this dimension properly in the next topic. I know somehow we'll be using dimension before, but after this we should be doing the right thing this time. Dimension your dimension line properly, your extension line done properly, your dimension figure placed properly, and every other thing. So in our next topic, that is isometric drawing, we'll be given a block, draw the block, and then dimension it properly. So if you get this, get the materials, study the material very well, and then learn how to use each of the different types of dimension, either chain dimension or baseline dimension, or the combination of the two. Okay, in this there is no restriction. Now, since dimension line cannot cross each other, there are some parts that are too complex that you cannot use one method alone, so you are allowed to use two methods. So practice dimensioning, and then if there's any issue in the course of doing so, reach out. We'll see you again in the next video. Thank you, and God bless you.